Welcome class to the first day of this new unit. We had a day on remembering how to graph lines and read lines that are already graphed. But today is the day we actually get into what the new unit will be about. And we're going to start talking about scatter plots. And scatter plots, it's a good name for it. It describes what it really is. It's a graph where you just put a bunch of dots on where data falls. So I have this fake one here, so this is not a real scatter plot, obviously. And there's stars, and they each one of those should represent a student in my little fake scatter plot. So what a scatter plot does is it takes two pieces of data about one thing. So if you take a look at the star, for instance, this would be a student who has spent this much time in class. I don't label my lines very well on this fake one. And because of that, he is this cool. Not something you can actually measure. But I just did it as a little joke, because clearly the more time you spend in class, the cooler you become. And that's what a scatter plot is all about, is deciding based on a bunch of data if something is true or not, if there's a trend that happens possibly. And today we're just introing it. We're just figuring out what a scatter plot is and how we can use them and how we can make them. So it's in this wider unit called bivariate data. So that word bivariate, we can separate it a little bit. And bi means two, just like a bicycle has two wheels. And variate means variable. So bivariate data is a piece of data that has two things you measure. This could be your age and your height, or the amount of calories you take in daily and your weight. So it could be anything like that, where you wanted to see, hey, is there a correlation between these two things? I'm going to measure this. I'm going to go out and find a whole bunch of people and measure those two things. And what you do is you put them on a scatter plot and see if something happens over time. All right. This is some more examples of scatter plots and the way in which they cluster. So we highlighted this word here, clustering, also known as associations. So an association between the variables in bivariate data can happen in three basic ways. They can be strong. So in this one, if I were to try to connect all these dots, I hit a lot of them as I draw a line through them. It's when all of the data clusters along a line, that would be a strong association. It means as one variable increases, the other one kind of follows along. A weak association just starts scattering a little bit more. So as I draw a line through, I only hit a couple points. And it just means that the association or the correlation between two things is not very strong. And then there's something at the end with no association. So if we can't determine what direction things are going in, if we can't make any predictions about anything that comes next, we call that no association. So examples of these things would be, so if you go back to strong association, if you were measuring someone's height, so if we wrote height right here, and then age right here, maybe we only went up to like 16 years old. This makes sense because nearly everyone on Earth gets taller as they get older. So that would be a very strong correlation, because not many people veer off from that path. A weak association might be something more like weight. Oops. It might be stronger than this one, but weight and age. Especially if you started at 16. If you started at 16 and went to, let's say, age 50. Because when you're young, obviously the older you get, the heavier you get because you're growing. But generally people get to a healthy adult weight by the time they're, I don't know, 20 something. And so if you take a look at 16 to 50, it would be pretty weak because, yeah, people generally weigh a little bit as they get a little older. not talking about myself, of course. That never happens. But it does change. It does vary more. And then no association is something that has nothing to do with each other generally. So you might take, how about bowls of cereal. Can't spell sideways here. How about bowls of cereal this morning and your golf score. So two things that have nothing to do with each other. And it shouldn't have an association. I would be very weary of data that said the higher your golf score, the more bowls of cereal you have eaten. Really wouldn't make any sense. We're going to get through the next slide and then end this video so that they're a little shorter this time. But at the very bottom you see strong association. So it says, if the variables have a strong enough association, you can probably determine whether the pattern is positive or negative and linear or nonlinear. And that's all on the next slide. So this only works if it's, I know you can't, it's kind of cut off at the bottom, but we'll get there. This really only works with strong and maybe even weak associations. Because if it's no association, you can't say the rest of this stuff. So if something is strong, it can be strong and positive or strong and negative. So I already gave an example of a strong positive association. That would be maybe height and age. A strong negative association would be something as simple as, how about miles driven? I know I'm squeezing these in. Miles driven and gas left. Well, that makes perfect sense. Of course it would go down. It'd probably even be, should really be stronger than it is. But the more miles you drive, the less gas you will have left in your tank. So that would be a negative association. Moving down here to the bottom, I'll get these out of the bottom part here. Linear or nonlinear. So both of these are positive. Both of these down here are positive, but they could be negative too. So this first one's strong and linear. Again, this is the same thing. So if I wanted to again say height and age, I could do that. But strong and nonlinear would be they cluster, but the pathway is sort of curved in some way. So we had a really good example of one that's really curved, which is if you think about running. So running the mile. If you were to run the mile at age 1, well, you wouldn't get very far. If you were to run the mile at age 100, you wouldn't get very far. So somewhere in between, well, I guess 50 is in between. That might be pushing a little bit. Maybe right about here, 25. I would say most 25-year-olds would be at their sort of peak performance of the mile. But lower than that, you're going to have a long time. So this would be like, I don't even know what a bad mile time is. We'll say 20 minutes. That's terrible. So 20 minutes, we'll say, I think the best time ever was around a 3-minute mile. I know that was like a famous milestone. Get it? Milestone? Haha. Okay, so you're not going to be anywhere close to 3 at 1. You're going to be probably not even close to 20 minutes. I don't know how you get a 1-year-old to get around the track 4 times, but you know, your dad is going to be way up here. You probably wouldn't even start at 1, because who's going to measure a 1-year-old running a mile? But it may start somewhere around, I don't know, 7, 8, something like that, when they start officially doing it, and they're not great. But as you get closer to 25, they get down closer to that 3 area, and then over time you start like slowly losing it. This is a terrible graph. I probably should have spread out the bottom more, but it kind of has this curving action where you have a peak performance age, and on either side of it, it's not so great. So that would be a good example of why something would be strong but non-linear, because everyone who you measure kind of has the same pathway in life.